Whenever we have formulas like these for calculating out surface area, just any type of formulas in general, we should be thinking about how does this tie into things that we already know. So what is some surface? What is a surface that we should know off the top of our heads what the surface area of it is? Well, how about a sphere of radius r? Let's use these methods to find the surface area of a sphere of radius r. And so you should kind of know in the back of your mind, surface area of sphere of radius r is 4 times pi times r squared. That might feel familiar from high school geometry. Let's see if we can derive that formula using this method right here. So once again, let's just write down, I think we did this in an earlier example, r of phi comma theta. Our parametrization is going to be r sine phi cosine theta and r sine phi sine theta and r cosine phi. Okay, so we know that we need r sub u and r sub v, or in this case, we're doing partial derivatives with respect to phi and theta. So partial derivative of our parametrization with respect to phi is going to be, let's see here, so our cosine phi times cosine theta. This would be r cosine phi times sine theta. And this would be negative r sine phi. We also need the partial derivative of this with respect to theta. And so we end up with, let's see here, negative r sine phi sine theta. Derivative of this with respect to theta is going to be r sine phi cosine theta. And there's no theta dependence here. So that partial derivative is 0. So we have these two partial derivatives here. We need to take their cross product and then calculate out the absolute value of that. Okay, when I say absolute value, the magnitude there. Okay, so r sub phi cross r sub theta is going to equal, okay, cross product, I hat, j hat, k hat. Been a while since we did a cross product. R cosine phi cosine theta, r cosine phi sine theta, negative r sine phi, and negative r sine phi sine theta, r sine phi cosine theta, and 0. Okay, so when we do the cross product, it's going to be I hat times this is 0, minus this times this, which would be negative r squared sine squared phi times cosine theta. And then minus j hat times this is 0, minus this times this. Would be the minus signs cancel out, r squared sine squared phi times sine theta plus k hat times this minus this times this. So r squared cosine phi sine phi and cosine squared theta. And then minus this times this, the minus times that minus is plus r squared sine phi cosine phi sine squared theta. Okay, how do we simplify this? We should be looking to simplify this. Well, the coefficient here of k hat is going to be, let's see, so we have r squared cosine phi and sine phi in each of these terms. So it would be all of that times cosine squared phi plus sine squared phi. And we would be left with, that is equal to 1. So the k hat term would just be r squared cosine phi sine phi. The I hat term, those minuses cancel, so we'd have r squared sine squared phi cosine theta. And those minus signs cancel, so we'd have r squared sine squared phi sine theta. Okay, so our cross product is going to be equal to this. Let me recopy it here. Because remember, we don't actually care about the cross product itself, we care about the magnitude. So the next thing that we need to do is to calculate out the magnitude. The length here. So this is going to be the square root of this expression squared So let me just, r to the 4th sine to the, I'm making a bit of a mess here. Let me recopy that. R squared sine squared phi cosine theta squared plus r squared sine squared phi sine theta squared plus r squared cosine phi sine phi squared. All that under the square root. So we end up with r to the 4th. We'll have r to the 4th in every single term there. So I'm going to factor that out. And then it will be a sine squared phi, sine to the 4th phi and sine to the 4th phi. So I can factor out sine squared phi from all of the terms. Then this leaves us with sine squared phi cosine squared theta plus sine squared phi sine squared theta plus cosine squared phi. Okay, so again, we should be looking, does this simplify? Yes, it does. So a little bit of sideboard here. This expression right here is equal to sine squared phi times cosine squared theta plus sine squared theta plus cosine squared phi. That's 1. And so it's sine squared phi plus cosine squared phi. And that's also 1. So all of that expression there is 1. And so we're just left with the square root of r to the 4th sine squared phi. And this square root ends up as r squared sine phi. For the values of phi that we're thinking about, sine phi will be positive. So the square root of sine squared phi will just be sine phi. Okay, so deep breath. We did a lot of crunch work here to figure out going from here to here to here. We figured out the magnitude of the cross product here. So now, what do we have to do? We just have to integrate this. So surface area is the integral of r squared sine phi. One last thing we should be thinking about, what are the bounds here? So our standard bounds for spherical would be phi runs from 0 to pi, theta runs from 0 to 2 pi, and so these are the bounds. And so to finish this off, we just need to evaluate this integral. Okay, so I can rewrite this as theta from 0 to 2 pi d theta. Pull out that r squared in front of everything. phi from 0 to pi sine phi d phi. So this is going to be r squared. This will give us 2 pi. Antiderivative sine phi is negative cosine phi. Plug in phi from 0 to pi. And this is 2. And so sure enough, we end up with 4 pi r squared. And so this confirms our high school geometry knowledge about the surface area of a sphere. So to wrap this up, we will definitely be using spherical parameterization. So many sheets here, I need to get them all straight. We'll definitely be using this a lot more in the future. In the future, we won't have to go through all of this. We can jump straight from here to the cross product, and then jump from the cross product down to the magnitude of the cross product.